So hello guys, today we are going to start the fundamentals of soil science course. The code name for this subject is SSC-111. So first of all, we are going to see the definition of soil science. The science dealing with soil as a natural resource on the surface of the earth, including petrology. Mainly that includes three important things, and the physical, chemical and biological and fertility properties of the soil, and these properties in relationship or relation to their management for crop production. Mainly this branch of science deals with the soil. Soil is a dynamic natural body which is present on the earth's upper crust, and if we see in this subject deeply, then we will see the things like how soil is created, how soil is related with crop production, what are the classification of the soils, what are the different division of soils in specific area or country. So we will know all that things. Also the physical characteristics of the soils, means what is the texture, what is the structure of the soil, what are the different types of pores that is present in the soil. Chemical features means or properties means it actually consists which minerals or how much organic matter it does it contains. Biological and fertility properties are also related with crop production. If fertility is good enough, then the productivity of the soil will be good also. Maybe not, but that will help to provide an importance in the productivity. So these things will be learned by this subject. So this subject has many branches, mainly soil fertility, soil chemistry. Soil fertility is just the inherent capacity of the soil to produce all the essential nutrients. We'll see the essential nutrients in other slides. So then in the soil chemistry, we will deal with the chemical components that are present in the soil, like minerals, organic matter, and we will know their properties, what are the reaction that are occurring with them in the soil with the help of microbes. We'll see all that things. After that, we have the soil physics. Soil physics mainly refers to the physical properties of the soil, how soil texture is, how the structure is. Also, we will know that soil has pores that is consisted by air or water, and it also consists very less amount organic matter. We'll know all that things. After that, we have the microbiology. Soil microbiology mainly refers to the microbes that are present in the soil. We'll study the microbes, how they are useful, what are their classification, and what are their roles in the transformation of any substance into soil. After that, we have the soil conservation. Soil conservation, it's actually the technique or the study where we get to know how to reduce the erosion, and if we can reduce the erosion, then the soil will be held by the plant easily, and after that plant can easily use that soil nutrients that are available in that root zone. So that will be very helpful. But if in time any flood comes and drain out all the soil particles, then trees or plants will not have any medium to grow. So that is very important. So we should know what are the conservation practices. After that, we have the pedology. Pedology mainly refers to three components, that are genesis, survey and classification. Genesis means it is the process by which soil is created, mainly weathering process, and other also processes are there. After that we have survey. Survey mainly refers to the different surveys that are conducted by many companies or institutes to describe the soil of any specific area. After that we have classification. Mainly after knowing these things by the survey, we will classify the soil according to the country or the area that is present in that country or continent. We'll all get to know that things actually. After that we have the definition of the soil. Soil, it is defined as natural dynamic body developed as a result of different pedogenic processes which takes place during and after weathering of rocks, and in which all forms of life are able to grow, mainly macro and microorganism. Mainly if you see that what is soil, then you can just simply define it as it is a natural resource that is present on the earth's surface, and it is created by some pedogenic processes which includes weathering process. Weathering is very important because by that process rocks turned into regolith, and after that some processes the regolith turns into soil. So that is a very much important step, and soil that gives the medium for growth of any microorganisms or macroorganism like the plant or crop. We can say that whole plant families or kingdom is grown on the soil. Not all the plant families, but most of the plant families. After that we have weathering. Weathering mainly refers to the transformation of solid rocks into parent material or regolith due to physical and chemical change. Mainly physical change by air or water or temperature. Chemical change means by hydration or by carbonation. That things are there. Also biological weathering is also there, that is done by rodents, humans, and other microorganisms. So these things are included in weathering, and by that process rocks are just turned into parent material or regolith. And what is regolith? Regolith is unconsolidated parent material which lies on hard mass. What does that mean? Mainly if we see, this is a hard mass of rock, then some deterioration or breaking of small parts will occur on the surface of the hard rock, and that small particle will be present on that rock. So that is mainly the unconsolidated part of that hard mass is called as regolith. Okay, after that we have the different approaches of soil science. Mainly the pedological approach is there. Pedological approach means origin of soil, and it includes survey, classification, and also genesis. Mainly pedological approach describes about how soil is created, what are the techniques for survey, and how it is classified, and also we will examine the soil in the field. So these things are mainly described or studied in pedological approach. But in edapological approach, utility of the soil is mainly checked. How we can use the soil as a medium for plant growth by its fertility and productivity properties. So that thing is related with this approach. After that we have the soil fertility and productivity. If you see soil fertility is the ability of the soil to supply all essential nutrients. It is the inherent capacity of the soil. Mainly essential nutrients are the number of essential nutrients is 17. So it should be present in balanced proportion and available form to the plants. Mainly there are some macro elements or nutrients and micro nutrients. Macro elements, this CHO, these are basic elements. Then we have the primary elements that are NPK, and we have the secondary elements that are sulfur, calcium, and magnesium. And after that we have the microelements, that is iron, manganese, zinc, copper, molybdenum, boron, chlorine. Then we have the soil productivity. Soil productivity mainly refers to the soil property, that how we can use soil as a medium for growth of the plants. It helps in the production of the crops. That thing is dependent upon the fertility of the soil. So all the productive soils are fertile, but all fertile soils may not be productive, or may be productive, because if we see that we have a balanced proportion of all nutrients in the soil, but we don't have proper water management or irrigation, then the plant cannot take the nutrients from the soil. Maybe that can happen. And also there are other management practices. Maybe weed occurs in that situation when we cultivate any crop. So that time the plant may get defected or affected by that weeds, or maybe by pests. So that things may happen. So all productive soil will be always fertile, but fertile soils, they need management practices. If that is not present, then soil will not be productive. So you may get the difference between soil fertility and soil productivity. After that we have the composition of the earth crust. Composition of earth crust mainly refers to the composition that is mainly rock. Rock is made up of small atoms, and out of 106, it is written, but it will be 118. Out of 118 elements, there are 8 sufficiently abundant elements that are present inside the earth surface, mainly up to 16 kilometer, and their weight is very much. About 99% weight is contributed by these 8 elements, that are oxygen, that is 47% weight, giving the 47% weight. Then we have silicon, that gives around 28% weight. Then we have aluminium, iron, calcium, sodium, potassium, magnesium. If you want to remember the percentage, then just remember the oxygen is the first, then we have silicon, and just remember these things: aluminium, we have iron, we have calcium, sodium, potassium, and magnesium. You don't have to remember the percentages. After that we have the weathering of the rocks and minerals. Mainly rocks and minerals are formed under a very high temperature and pressure, exposed to the atmospheric condition of low temperature and pressure, and they become mainly unstable. So rocks are turned into regolith. We have discussed what is regolith. So by the process of weathering, the big particles of the rock, or broken particles of the rock, just turned into very small particles that are regolith, and after that by some soil forming factors or processes, they turned into true soil. So this the given thing here. After that we have the soil. Soil is derived from the Latin word solum. Mainly here we describe the origin, that means floor or ground. You can just remember it. After that we have the Dokuchev's definition. Dokuchev was the father of soil science, you should remember that. And we have another definition by Jenny. Mainly this definition you can just read, but they are not very much important for the question papers. So you can just write the previous definition. After that we have this thing: soil serves as a medium for plant growth. These are the characteristics of the soil, and for microbial activity, you know this thing. And it also works as a sink. Mainly it consists the whole water land or the hydrosphere, and also it is a recycling factory for numerous waste. We can put the kitchen waste, industrial waste, agriculture waste on the soil surface, and they will just recycled. After that, it supports our buildings. Mainly it gives a medium, and also it provides the material. Mainly the sand are the portion of soil. So they are very much needed for the construction of the many structures like dams, road beds, schools, roads, all the things. After that, we have the spheres of earth. Mainly earth consists three spheres. We all know that that is lithosphere, that is the solid zone, and we have the hydrosphere, that is the liquid zone, that is mainly water, consists of water, and that is present on sea surface, ocean surface, and also it is present on some areas on the lithosphere, like pond or lakes or rivers. After that, we have the gaseous envelope, that is surrounded by surrounded on the earth surface. So over the earth surface, that is called as atmosphere. If we see this is the earth, then in this area the atmosphere is present. So you can get the pictures online, search it on Google if you want. After that, we have lithosphere. Lithosphere, it is the solid sphere, and it consists continents, ocean basins, plains, plateaus, mountains, valleys, dunes, lava flows, and fault scarps. Just remember 5-6 things. Just you can write if question comes here. From this part, questions may not come, but you can just revise these things. After that, we have the interior of the earth, that is that consists rocks and minerals, and then we have it is covered by the gaseous, mainly atmosphere, and watery envelopes, some parts of the hydrosphere too, and the amount is about 93.06% of the total earth mass, that is contributed by lithosphere. After that, we have hydrosphere. Hydrosphere, it covers almost 75% of the earth's surface, and that is 10 kilometer deep, maybe 10 kilometer deep in sea levels, and occupies 70% of the earth's surface. After that, we have the it contains absorbed air, carries many particles of rocks as sediments. We can see there are many rocks that are present inside the sea or oceans, and it is lies within the ocean basins. Also, it is appears on the surface of the land in the form of rivers, ponds, lakes, or as groundwaters. So that is for hydrosphere. After that, lastly, we have the atmosphere. Atmosphere, it is just creating an envelope over the earth, and it is 322 kilometer area is there over the earth's surface. After that, we have that it covers both lithosphere and hydrosphere, and it is called as atmosphere. And then we have some gases that are present on the atmosphere, mainly nitrogen. We all know that it is 78%, oxygen that is 21%, carbon dioxide is 0.03, and argon is almost 1%. And also there are other inert gases like helium, neon, krypton, xenon that are also present. And water vapor content in atmosphere varies from place to place and time to time. After that, we have the rock. The hard naturally formed substance of earth is referred as rock. So 8 elements constitute 98% of the weight. They're almost about 99% of the weight of total earth crust, and 2 elements comprises 3/4, means almost 25% of the total composition of the earth crust. And sorry, it is 3/4, means 75% of the total earth crust. So that are only oxygen and silicon. So these are present in non-metallic form. These are mainly non-metallic, and they are present in ionic forms. Oxygen constitute about 47%, and silicon constitute about 28%. And there are also other metallic substances or elements like aluminium, iron, calcium, sodium, potassium, and magnesium. After that, we have the soil components. Mainly soil consists four major components, that are inorganic or mineral materials, then organic materials, water and air. If you see, this is soil, then if we create a round surface, then this part, it is solid space. If it is solid space and if it is porous space, then here the 45% will be contributed by the minerals, and here only 5% is contributed by the organic matter, and here we have the soil air, that is around 20%, and also we have the soil water, that is around 25%. So that is written here only. The proportion of the air and water are subjected to rapid and great fluctuation. Mainly, it is saying that the 25% air and 25% water, that is not actually very much precise for any soil, because it may change. If soil water capture all the pores of the soil, then there will be no space for soil air. So aeration problem will be there, and other problems will be also there. So the percentage of the soil air and water, that may change, but almost the 45% mineral component will be constant almost, and 5% organic manure or organic matter will be also like constant. After that, we have the mineral matter. So mineral fragments are that 2.0 to 75 millimeter are known as gravels. This is the size given for gravels and pebbles, and other rock fragments like cobalts and cobalt flags. These are around 75 to 250 millimeter, and if we see the size is more than 250 millimeter, then it will be called as stone or boulders. After that, we have soil. After that, we have the soil particles. Soil particles, if it is around 0.2 to 2.0 millimeter, then it will be called as sand. And sand, that will be gritty type. And if we see the size is around 0.02 to 0.2 millimeter, then it will be called as fine sand, and that will be also gritty. And if the size is around 0.002 to 0.02 millimeter, mainly this, so that will be called as silt. And silt is powdery like substance. If we just touch it, then we will feel like that is powder, the softest mineral. And we have lastly clay. Clay is sticky and its size is very less, that is less than 0.002 millimeter. So that are the things. After that, we have the proportion of the different size particles, mainly texture determines the nutrient supplying power of the soil. And also primary minerals, that are original minerals, that is NPK. NPK are prominent in sand, silt fractions. Then we have the secondary minerals, that are CAMGS, mean calcium, magnesium and sulfur, that dominant in clay fraction and in some cases in silt fraction. After that, we have the inorganic fraction of the soil is the original source of most of the mineral elements that are essential for plant growth. So that is another thing. So this part is not very important. You can just exclude these things, only this page, okay. After that, we have the organic matter. So organic matter, it comprises an accumulation of partially disintegrated and decomposed plant and animal residues and other organic compounds synthesized by soil microbes as the decay occurs. Mainly it is saying that if any plant is broken down, or the leaves or twigs and branches is broken down, then it will be turned into organic matter. after some days, and that will be synthesized by soil microbes. Not only the plant material, animal residues will be also changed into organic matter. So this organic matter is very much important for soil, and that is mainly present on the topsoil, and its percentage varies from 1 to 6%, and it is very less in subsoil. If we see the soil surface, then it is on the uppermost surface we have the topsoil, and in the lower portion of this topsoil we have the subsoil. So this is the just a diagram, and in respect of soil productivity, organic matter plays an indispensable role. So indispensable role, so that is important thing. Mainly indispensable mean very important role. After that we have the soil water. Soil water with its soluble constituents makes up the soil solution, which is the critical medium for supplying nutrients to growing plants. Mainly the nutrients taken by the plant is done through the roots, and roots absorb the water, and the soluble constituent or nutrients just taken out from the soil to the plants. And so soil water plays a very important role for controlling the energy balance of the soil and regulates the gaseous exchange in the upper layer of the soil. Mainly the transpiration, photosynthesis, these things are maintained by soil water too. And the presence of water in different amounts in soil governs the thermal, mechanical, physical, chemical and biological properties. So you can just remember these things. I don't want to explain these things. After that we have the soil air. Soil air, the content and composition of the soil air are determined by largely by the water content of the soil, since air occupies those soil pores not filled with water. As I said before, if pores are already captured by the water, then air will not get any pore spaces. So soil air always differs from the atmosphere air. The percentage of carbon dioxide is around 0.03 in atmosphere, but in the soil that is